Hello, friends. Welcome to the ATC Double Cut. In this episode, which I've been looking forward to for a long time, we have a guest, TJ Creamer, the golf course superintendent from Olympic View Golf Club in Victoria, British Columbia, and we're going to be talking about something that, listen and see. I think this is absolutely fascinating. So welcome to the show, TJ.
Micah, thank you very much for having me again. And I think this is round two. We tried this around Christmas time, had some technical challenges. So glad to be back.
That's right. I apologize for that. I wasted both of our times as we recorded a episode, and you told me about 10 minutes in, you're like, Micah, this I'm not really hearing you. This is really breaking up, and I said, well, let's just keep going a little bit, but not make it too long, just in case it actually records better than what we're hearing. And it just progressed worse and worse. We cut it off after 20 or 25 minutes, and it was just the problem was I was at a place in Japan with extremely slow internet, but I didn't realize how slow it was. And because of that, a video call just didn't work at all. Hopefully today, the technical problems don't happen and we can talk about what we want to talk about, which is organic matter at the surface of putting greens and sand top dressing and surface performance. And it's actually better now that we're recording now, because since we recorded in December, you collected another round of OM246 samples, sent them to the lab, and got those analyzed. So we can talk about that. And the results continued the trend that you've been seeing for a few years.
Yeah, absolutely. It was a great break for us to be able to get that data and then reinforce what I was already hoping. It's Christmas for me every time of year when we get the OM2 samples back, and it didn't disappoint this year. So it's nice to see the trend continuing to go in a downward direction, which is our current goal. And now we're actually trying to level off from where we're at. So.
And that's something that we're going to talk about in detail, because I think you've got the kind of OM2 timeline, the total organic material at the surface of the green in the top 2 centimeters. You've got the kind of timeline over the past few years that would be the envy of many golf course superintendents, because if they're trying to bring it down in a steady manner, because you've seen that happen, and so we'll talk about how you're achieving that, what you're doing to achieve it. But considering that we're on the ATC double cut, we better talk about one of the ATC blog posts, and this one's about sand top dressing. So we'll kick it off with one of the posts, and then talk about the specific results that you're seeing. The post I want to talk about, TJ, which I'll put a direct link to in the show notes. This is what we tried to talk about back before Christmas when we had that bad connection and didn't get a recordable show, was this post with the title GVX and Sand. Somebody had asked me if there was a good way to adjust their sand top dressing rate based on the GVX. The actual growth of the grass compared to the expected growth of the grass. And I said, no, I don't really think there is, because I don't want to use GVX for that. And I thought that TJ could probably say he doesn't use GVX for that either. Do you, TJ?
I do not, no. So GVX is great for looking at where growth is at during the season and making nitrogen decisions during the season based on the 14-day GVX. But as far as top dressing, that's something that I'm evaluating with OM2 numbers on an annual basis, and then making adjustments on an annual plan based what those numbers come back at. So,
and I'm going to explain without looking into the blog post too much, but I explained it in the blog post, and I encourage you to, anybody who's listening, to go ahead and check out that blog post if you haven't seen it yet, to get the specific explanation. But basically, the reason why the GVX is not something we want to use for sand is this. If I was in Edmonton, it's going to be cold, and I have a relatively short growing season. If I'm in Singapore, right near the equator, I have a 12-month growing season, and I will be growing a lot of grass. So we could have a GVX that's identical in Edmonton and in Singapore. A GVX in Edmonton of 50 would mean that we're growing the grass at 50% of the expected amount. So generally for high quality turf surfaces, we will try to grow the grass at less than 100 usually. So let's say we're growing the grass at 50% of expected in Edmonton. Well, the grass is going to grow some amount. Now let's go to Singapore, where we have a 12-month growing season and we have a 100% growth potential almost every single day for warm season grass, or certainly a growth potential that's above 80% every single day. We could run a GVX of 50 in Singapore, and that's going to be like 5 or 6 times as much actual growth as what a GVX of 50 would be in Edmonton. And so the GVX is something that's just relative to where you are. And the actual sand amount in Singapore might need to be about 6 times what it is in Edmonton, even though the GVX would be identical. So that is the way that I typically explain it. And I sort of did that in the blog post, but I didn't use those specific examples. But in that example, I used London, England, and Singapore. So I gave a lot more details, but I want to focus on what's at the end. The way I really like to do this is to measure the total organic material by depth, the OM246, and then to calculate a sand amount based on that. So I want to jump into how you actually do that, TJ, because we're not going to do this by GVX. We're going to look at OM246 and calculate a sand amount based on that. That's the way that I like to do this.
Yeah, so I use is it Shinny app or Shiny app, Mike? I never know which to say.
I've always pronounced it shiny.
Okay,
Is Shinny a hockey game?
it is. It absolutely is.
So yeah, I can see why that name might that pronunciation might come to mind. I call it shiny. Shinny is fine if that's how you refer to it.
It'll have to be in your next grammar of greenkeeping.
Yeah,
Edition.
we should have a pronunciation key.
I'll take so when I started Olympic View 5 years ago, I took initial OM246 samples, and so that's my baseline OM246 numbers. Great. It doesn't tell me a whole lot at that point, but just I'm just learning where I'm at. So then the second year, a year on, I took the samples again, and now I have 2 samples to compare, and I also have the amount of top dressing that I put down in that single year. And from that, the app will calculate an organic matter accumulation rate. And then I can enter in what my desired OM2 number is for the following year, and it will provide me with the amount of sand that I should put down if I want to achieve that OM2 number the next year. So if I want my OM2 number to go up, it's going to recommend less sand. And if I want to go down, it's going to recommend more sand. I think that makes sense.
Yeah, that makes sense. I brought up on my screen. I'll put a direct link to this calculator for anybody who doesn't know about this. It is quite useful because it's using how your organic matter changed last year compared to how it was expected to change given the amount of sand that you've applied to calculate the exact accumulation rate at your site, which is taking into account how much is being produced, how much is being decomposed, your specific microbial community and how that is working to break things down, your grass type and how that material breaks down and just the way that you manage. So it's very site specific. So let's see if we go. So that's that calculator. So yeah, for those of you listening, I'll describe what we're saying. This is an online calculator, which means you can put in some numbers, and it will give a calculation. So for example, the first tab, it has different tabs. They're OM accumulation rate, sand requirement, unit conversions, and then details about this. So for example, if we just were working with a 2 centimeter layer, and if we had a starting organic matter of 5% and an ending organic matter of 5.2%, and if we added 1 millimeter of sand, then in that layer we would be accumulating organic matter at 5.2 grams per kilogram of soil per year. It might seem that this calculation should be extremely simple, but there's a lot of moving parts in it, and so this calculator is the only one that I'm aware of that's actually going to calculate this for you, and then you can go make some other calculations about your sand requirement. So if we go look at the sand requirement, if we're
that first one, Micah, just gives you a calculation, say, for last year. That's your info for last year, which then now you're going to move to the next screen to go say, okay, what do I want to do this year?
Yep. And so if we want to figure out how much sand we want to apply now, let's say we're at 5 and we want to be at 4.8. So it's going to say that if we continue accumulating organic matter in the top 2 centimeters at that same rate that it did last year, then we need to apply 2.8 millimeters of sand over the next year or over the upcoming year.
Yeah.
And then some people are saying, what's with all this millimeter stuff? And well, the next tab shows unit conversions. So if you're working with millimeters, kilograms per hectare, pounds per 1,000 square feet, or cubic feet per 1,000 square feet, you can select the unit that you want to work with, and you can put in the amount of sand that you're using in that particular unit, and the table will update to show what the equivalent amounts of sand are. So, for example, 1 millimeter of sand is 319 pounds per 1,000 square feet. So this is something that I encourage everybody to be familiar with. Be familiar with how much sand you're applying. And if you're doing OM246 testing, I would encourage you to use this calculator because, let's talk about some of the results that you've seen, TJ. You've been using this for a while. And should we look at the timeline of organic matter from your test results?
Just want to make a note on the top dressing measurement. I think, we use a tray and we capture a weight and have a known area so we can calculate a depth each time, which you have some blog posts about as well. I think if you're just using a volume, like say you ordered X amount of green sand this year and use that over an area, you're going to be putting a lot of that sand on collars and such, and maybe a bit of surrounds. Whereas if you can use the tray method and get a rate, it gives you a much more accurate measurement if you're using it to calculate within your Shiny app.
Yes. So I've often talked to people, and they know that they got so much sand delivered, or they know they filled this many hoppers of sand and put it out. And I found that the error involved in that is surprisingly large. So it's been of a magnitude of about 25 to 50% error, which is usually, and that's in the best. I've seen it actually worse, but generally, if we're really careful with that, it tends to overestimate how much sand you're applying by like 25 or 50%, and it's surprising how much error is involved in that. So what I recommend is take the little bit of extra time to measure how much sand is going out, which can be done with a tray, can be done with a towel. The USGA has a video about it. I'll put a link to that also I've got a blog post about some different ways to do that, and a video that shows my recommended method. All right. Let's look at your results, TJ. Can you talk us through uh, what this timeline looks like?
Sure. So the left one is the one that I'm always most concerned about. So the OM2 numbers, and you can see my numbers slightly below average in my first sampling year. And I'll say I didn't really know what I was doing as well with the system back then. So my second year, I did reduce the amount of sand going out. And then you could see at the start of my third year, my OM2 numbers had climbed up quite high.
TJ,
And
say TJ, say what the actual
oh yeah,
numbers
sorry,
are,
sure.
so that those listening can draw
Yeah.
a picture in their mind of what these numbers are.
Yeah. So we'll picture the mind of climbing the mountain and start at 6.7% average, and then 8.5 starting my second year, and then we peaked at 10.7 starting my third season. So that second season definitely backed off on the top dressing. Thought I was fairly low on nitrogen, which we were around 1.75 pounds for the year. But the organic matter numbers still went up significantly. So starting for the third season at 10.7, we were able to bring it down to 8.8 starting the fourth season, and then 8.2 starting the fifth, and then we're down to 7.7, which is pretty bang on average to start this season. And the notable thing about that is that doesn't involve any traditional aeration, definitely no core aeration. One 3/8 solid tine aeration in the first season, a couple of deep tine aerations in the early few years, but the last 4 seasons we really haven't done any aeration at all, aside from needle tining, and even the needle tining we've reduced down to almost zero as well. So this is purely top dressing. There is some verti cutting, which I call more verti grooming because it's not super aggressive. It just makes a little bit of room for some sand to hide. But this is just managing nitrogen amounts fairly judiciously, and then applying top dressing on an individual green basis to bring the higher greens down more. They get more sand, and the lower greens actually get less sand. So
Yeah, so we're going to talk about that in some detail because that's fascinating. How that's been working out for you also. The and you're on a site with some greens that don't see any sun in the winter, and even in the summer they must be shaded for a good part of the day.
I think that's one of the reasons that it pushed me down this path was we had just have so much variability at Olympic View. We have beautiful stands of mature Western red cedar and Douglas fir trees, but some of them are on that south side of many greens, and there's a mountain in play in some areas. So a lot of our greens have varying light conditions and makes it challenging to grow for sure. So with the variability has pushed me down a path of managing greens in a variable method to, in the end, achieve very similar results in performance.
So these are bent POA greens, and when we're talking about the average, where your 7.7 is right on the average at the 0 to 2 centimeter depth for greens. That's for bent POA greens. People who've looked at a recent OM246 report may have seen the table that shows what's normal for different species. And for creeping bentgrass, it's more normal to be around 6% or 5.8 or something. But for bent POA greens, there tends to be a bit more organic material right near the surface. So 7.7, where you're at right now, is what's normal for bent POA greens. And so you've made a calculation for the 2026 season to try to be right around 8%, if I remember our previous conversation.
Yes, yeah, we were shooting for 8.5 was our previous number, and the numbers are almost too good to believe as they keep going down. So I don't want to err on the side of potentially going up again. So I'm shooting for 8 this year and have programmed in some top dressing rates for greens to try and see if we can't get to that for the end of 2026.
So you've gone. So at the we're focused here on the 0 to 2 centimeter layer. That's what we're talking about right now. So you were in the winter of 2023. In February of 2023, you were 10.7% total organic material right at the surface of the greens. And you went in 2024, you were down to 8.8. In 2025, you were down to 8.2. And now at the start of 2026, you're down to 7.7. So you've gone from 10.7 to 7.7 over the past three growing seasons, the 2023, 2024, and 2025 seasons. And you pulled a core 0 times in that?
Zero
Oh,
times.
so
Yeah.
did you put sand into any holes? Did you punch solid holes and put sand into those?
No, we did not. The greatest thing we did would maybe be a heavier top dress and then a needle tine in behind on a few occasions through there, especially with the greens that we're trying to get more sand in. We'll top dress and needle tine those greens to work it into that top 2 centimeters a little faster.
Okay. So so that is that's interesting that even and these are bent POA greens, but they're dominated by POA. So they're probably 75-80% POA on average across the property, something like
Yeah,
that.
yeah, I'd say that for sure.
And so you've been able to get the organic matter to come down, and so that's partly by the top dressing, but partly it seems to just be happening. And now let's look at the or talk about the 2 to 4 centimeter depth and the 4 to 6 centimeter depth, because those also peaked around 2023. and and your 2 to 4 centimeter depth, where you haven't put any sand, you haven't pulled any cores to move that out, you haven't dry ejected to put sand down, you haven't punched any holes to put sand down, that in 2023 was 5.6. In 2024 it was 5.7. And then over the past two seasons, it's gone from 5.7 to 5.2 to now 4%. So that's gone from a peak right around 5.6, 5.7 down to 4%. And that's below the surface. What's going on there? It sure looks like it's decomposing.
That's what I have to read into that, Micah. It's I'm not doing anything in that layer, and it's similar in the 4 to 6 as well, going from the peak of 3.9 to 3.5, and now 2.8. So I think we're just doing a good job of using the nutrients that are nitrogen that's in the soil to not help create more organic matter, and then just having a good, efficient system that's working through. So.
I I have to ask. Um, I have to ask because remember the OM246 is measuring living and dead organic material. It's measuring the roots, and it's measuring rhizomes and stolons and and everything. Is there any chance that you're losing roots and losing rhizomes, and the grass is just way less healthy than it was?
We no, we see more healthy, like from when I first got there to now. We've continually improved the green's quality. We measure smoothness and green speed on a single green on a daily basis, year round, and we've seen those numbers increase on a consistent basis. And coming out of this winter, probably the healthiest I've seen them coming out of a winter. Here we're open year round, so generally through the winter months we don't grow very much, and we're continually getting traffic and play, so the greens take a bit of a beating, but they look fantastic. I'm really excited as we come into some partial growth to do a little bit of grooming and just get even more smoothness. But this past week we've been stimping mid tens, and I think the smoothness was I do 9.5. We don't quite call tens. I know you don't have halves on your scale, but really good smoothness this week, and that's just with a mow once a week over the past few weeks, and rolling on a daily basis, and not a lot of effort going into some big smiles on a lot of golfers with some sunny weekends over the past couple of years. So
Okay. So, because thanks for answering that, because I have to ask, because if the greens were dying a little bit every year, and let's say you had 100% grass cover in 2023 and 90% grass cover in 2024 and 80% grass cover in 2025 and 50% grass cover now, we'd be losing some. Of course, we'd be producing less organic material, and we'd have less roots and less rhizomes and so on to measure. So you'd expect this on dying turf also. So thank you for assuring me that the conditions are fine.
the greens are still there. So last I checked, which was a few hours ago. So
Very, very good. That's that is that is a good result. How much nitrogen are you putting over the past few years to achieve that? Because it's interesting that you don't pull cores and you're not putting a lot of sand. So let's talk about the actual amount of sand that's going out and the actual amount of nitrogen.
sure. So 2021, my first season, we were 10.5 grams per meter, which is just over 2 pounds. And then we've steadily reduced that every year until last season we were 4.6 grams, which is just under a pound. That's an average across all greens, but we do vary that from green to green based on growing conditions. But we've reduced our nitrogen by 100% over the past 5 years, and probably be somewhere around that same number this year because I think we're happy with that number. But yeah, that's it has just been they don't need it. We're meeting our GVX, so we wouldn't put more out. So.
And then what do the sand numbers look like?
So the again average numbers, but we started at 4.3 millimeters, then 3.31 in 22, 5.7 in 2023. So that was the year we really tried to bring that number down from its peak in the OM2. Just under 4 millimeters in 2024, and just 3.25 in 25, and we're forecasting around 2.25 in 26 to be able to meet our OM levels based on the accumulation rate from the past year. So steadily going down. So.
And to put those numbers in perspective, the minimum amount of sand that we often hear recommended is 6 millimeters. And the USGA currently, the last article I've seen from the USGA that recommended a standard top dressing rate was in the range of like 7.5 to 9.5 millimeters. So, and that 6 millimeter number comes from the work by Rock Gassois and Chaz Schmidt at University of Nebraska when they did a survey across the United States of what sand amounts were being applied at golf courses to allow them to keep their organic matter at a suitable level. And they proposed that the minimum amount that needed to be applied was 6 millimeters. And so you've never applied even as much as 6, and the USGA recommends a little bit more as a standard amount. They recommend a little bit more than that 6 millimeter number. So to put these in perspective, you've been applying about 33 to 50% of the standard minimum recommended amount, and you're still seeing the organic matter come down to a level where the greens can perform quite well. Were you having problems with the performance when the organic matter was higher, or were you just scared that the number was going in the wrong direction?
Definitely the latter. Just scared. We weren't seeing any infiltration issues. We weren't seeing scalping. We no concerns about holding water in the surface, but didn't. I'll say now, seeing the greens that were highest come down from that level, I think they're better than they were. And we did struggle with some summer patch on those greens, which we've been treating and haven't seen the last couple seasons. I will note that my 2 or 3 highest greens are OM2 numbers that are in full sun. We have pretty much consistently been around 6 millimeters of sand on those greens. We've seen the organic matter numbers come down. But so, yeah, on those full sun greens, that 6 millimeters kind of does work for us. But everything else has just limited light and then limited growth and then limited organic matter production. So it gets less sand than those. So.
I don't want to chase organic matter numbers in the soil too much, especially when the surfaces are performing well. And so the way that I would think of it as a advisor to you is when you first went there and the numbers went from like 6% to 8% to almost 11%, something like that. What were those numbers? They went from it went from 6.7 your first year up to 8.5 up to 10.7, and you were neither of us were so excited to see the numbers going up like that, but the surfaces continued to perform pretty well. And I guess the risk that happens is at some point it's going to be too much, but you don't know where that level is. And because we don't really know where that level is, we feel much more comfortable managing at something closer to the average value for the species instead of being on this trajectory of just going up and up and up and up and realizing that it's dangerous up there, but you're not quite sure when you're going to reach that.
I think more of the concern and why I noted I wanted to be at a bit higher number was when I first got there. There was a couple greens at 5.7 and 5.4, and those were greens that were struggling. They're shaded, they struggle with traffic, and then in the winter months, that's where we would see grass disappear. It just wouldn't hold up to ball marks. They would explode. And so we tried to get into a system where we're increasing the organic matter on those. And that was my biggest concern at the time.
So it was moving in that direction, but then we thought it went a little bit too far. And so then you've got this microclimate. Let's start talking about how do you practically decide how to adjust nitrogen rates, how to adjust sand rates, and then how do you accomplish that when you go to make applications or when you skip applications?
Yeah, so the top dressing, that's a bit easier one because, as I mentioned, that's something we plan, essentially. We don't have those checks and balances other than the OM2 numbers at either end of the year. So we will plan out using the Shiny app. I keep having to think about it every time I say it now. So
sorry. Yeah, just maybe we should it's like my name. So many people call me Mika, and I answer to Mika, and I'm so happy. I call myself Micah, but to me Mika is absolutely equivalent. And if my name is Mika to you, that's perfectly fine for me. And maybe the Shiny app could be the exact same thing. So yeah. I don't want you to have to think about it, and I don't want people to have to think about what they call me.
Yeah. So the first year we sampled a half a dozen greens. The second year we sampled all of our greens at the OM2. And then again in 2024 and 25, we sampled all the greens. So when I have every green, it allows me to establish an organic matter accumulation rate for each green. And then using our experience, seeing what we're seeing when organic matters are too low, and seeing greens not do so well, and then not wanting to be too high, we can set our number around 8.5, and then sort of set a prescription out for the year of how much total depth each green needs. And then I create a Excel table with, if I want to do applications every 2 weeks or every 6 weeks or whatever it is, how do I play with these numbers to get to the total based on how much we put out, how many applications and how much each app. And then we finally break that down into if we're going to go out and top dress, myself and my 2 assistants, I have 2 excellent assistants that are really ingrained in this as well. we look at it and go, okay, well, this green gets 0, this green gets 1 pass, this green gets 2, and occasionally we'll do 3 passes on a green. So there's a prescription every time we go out and top dress with how much sand is going to go out. And sometimes, rarely, it's all the greens, but most of the time it's 12 to 14 greens are getting sand out there when we go to do an application. So.
Okay, so for the sand, you're calculating this on a green by green basis because you're doing all of the OM2. You're testing all the greens for OM2, the total organic material in the top 2 centimeters. Could this be applied if somebody only tests 6 or 8 greens? Could they group it and say these greens are probably similar to these ones that are tested? And because you're actually breaking it down to 18 different greens, or maybe including your practice greens, you've got individual rates for each green that over the course of the year you try to put those amounts out. What about grouping it into like low organic matter greens, medium, and high? For example, taking 3 groups, and would that be feasible also?
Absolutely. I think 2 factors have led me to doing it this way is as I mentioned, lots of variability for Olympic view, but B, I really love numbers. So I love playing with the numbers to try and to dial everything in just as I want it to be. So, and as I mentioned, my assistants enjoy this as well. So, so we love the numbers, but I think other properties where you have more consistent green sites, then it would be a lot easier to be able to group some together and achieve the similar results without having to do as much testing. So,
And you said one thing I don't quite understand. You said sometimes a green gets 2 or 3 passes of the top dresser, but you said usually when you go out, only 12 or 13 or 14 greens actually get sand. So how is it that some greens get none, but sometimes you'd have to go 2 or 3 times over a green?
it just the way the formulas work, and then we'll do some things where in the summer we overseed with top dressing, or sorry, with bent grass twice, once in July, once in August, and we top dress all the greens when we do those top dressing applications. So that kind of gives us a good baseline to get a couple applications out on every green. There are some greens that really don't get much sand at all through the year. So those 2 applications might be most of what they need. So that's how we can end up the rest of the season where there's variability in the number of greens that go out each time. So
Okay.
does that make sense?
Yeah.
I'm looking at a spreadsheet that it makes sense to me, but I'm not maybe explaining it properly. So
It makes sense. I just want to think of somebody that says, hey, I had never thought of that before, but I've got shaded greens that have ball mark problems and they have really low organic matter compared to my other greens. And how do you practically, I'm sure some people do this already intuitively, but what you're doing is trying to track the OM2 numbers and then making a specific calculation of how much sand to put. So it seems to make sense to me. I think everybody can figure out how that might work at their operation. How does it work with nitrogen though? Because you said the sand you can calculate exactly. How do you calculate how to adjust the nitrogen rate green by green?
yeah, so I mean, we'll go back to the very start of the podcast and talking about using GVX for sand, which we don't do, but we can use GVX for nitrogen rates throughout the season. That's essentially, instead of doing a test once a year and having a check, we have a test every day that we mow, or every 7 to 14 days that we take that GVX average. So I'm looking at each green and their GVX average for the past 14 days. And we'll look at it, and if we're low on some and high on others, we decided a few years ago that it was worth pulling nitrogen right out of our application tank. So we'll often go every green with some iron, every green with some wetting agent, and every green with some N. Well, we wanted that control, so we pulled the nitrogen out. Now when we apply nitrogen, it's the only thing in the tank that goes out. So we have the opportunity to go, well, the first green is growing at 40 and we want it at 60 GVX. So it's going to get 2 passes, and the second green is growing at 60. It's right on. So it's only going to get 1 pass. And we can basically look at those individual GVX, and our rate of nitrogen in the tank is a 1/4 gram per meter. So if we go 2 passes, that's a tenth of a pound of N. So we can kind of vary that rate between 1 pass, 2 pass. I don't think it's very often we do 3, and there's definitely greens that we do no passes on throughout the season. So
What's your typical nitrogen application frequency?
10 to 14 days. So pretty normal, I'd say, in that kind of range. But we can stretch that. I mean, I love liquid fertilizer and liquid nitrogen because you have the option just to go, no, actually, we're doing really good right now. We're going to back off, or hey, we're just not seeing it, and maybe we'll go out in a week and have that variability. Go, well, let's go down with this small rate, and if we want to go again in 5 days because we're not seeing a response, then we can. So.
Okay, so now I want to show. I want to show the the timeline again, and let's look at just how variable this is, and for everyone who's listening to this. Yeah, I don't have a blog post about this exactly because this is just something I'm showing in the video. So maybe I'll do a blog post or something to show it. But for now, I would encourage people listening to maybe have a look at this section of the video, because in 2023 you had organic matter that was variable. It ranged from less than 8% at the 0 to 2 centimeter depth to more, I think one of those was over 13%. So it varied by 5%, by more than 5%. And the next year, it continued to be variable. If we look at this, and because each of the points on the chart, even though the average is 8.8, you ranged from about 6% to 11%. And the next year, the average went down to 8.2, but there's still quite a spread. And this year, the average is 7.7, but those points get closer and closer together each year. So there's this increase in consistency that you're seeing at the 0 to 2 centimeter depth, which I think is important because that's what the ball reacts with. That's where the ball's landing. That's what the mower is rolling across. And you're making that more consistent across all the greens year by year by implementing this variable top dressing and variable nitrogen rate.
Yeah, and I would just say on the extreme end, like our highest organic matter green, we put just over 6 mils of sand on last year, but we put just under 2.3 grams, which is just under a half a pound of nitrogen. So, and that green looked fantastic all year. It does have full sun, so I think it grows really efficiently. It's also a large green that doesn't get bothered by traffic too much. But then a putting green, or that it gets tons of traffic, it got 1.5 pounds or 1.75 pounds of N and barely a millimeter of sand last year because it just struggles with so much traffic that it needs that much more N and doesn't need the sand because we're not growing that much organic matter. So the varying conditions using those two greens, if we fertilized and top dressed those the same, I'd have exactly what we had previous, which was that green in the full sun had a way higher organic matter compared to that putting green. So,
and I've recently started calculating the coefficient of variation, which is the standard deviation among all the greens divided by the mean of all the greens. The coefficient of variation is the standard deviation divided by the mean multiplied by 100 to express it as a percentage. And then the mean absolute deviation, which is a slightly different calculation of how much greens vary. And the way that this looks since 2023, when you were at the peak of organic matter, the mean absolute deviation, which I think is the easiest one to consider, that had a value of 1.85 back in 2023. So what that means is, on average, when you stood on any green on the property, on average, it was going to be 1.85% higher or lower than the overall property average in organic matter. And you've seen that number go from 1.85, then you were doing the variable rate top dressing and nitrogen. You've gone from 1.85 to 1.53 to 0.74, and this year you're at 0.47. So you've cut that number down. It's 25% basically of what it was. It's so you're four times more consistent in 2026 than you were in 2023, and and this is now better than average. So the average in ATC's data set for the average golf course, the mean absolute deviation is 0.61 right now. And so you've gone from being three times more variable than the average course to now be more consistent than the average course. So that tells me that what you're doing is working, which is why I said at the very start, I'm so excited to talk about this because I think it's innovative. It's not innovative to micromanage your property. It's not innovative to do what you need to do to take care of the grass. But I think the innovation here is paying attention to these specific metrics, paying attention to these specific numbers, and then achieving this type of result over a multi-year period where we see the similar trend repeat itself year after year, and seeing that that's possible at your operation. So you're doing more than 50,000 rounds, right?
Yeah, absolutely. We'll be 55, 56.
And your maintenance crew, do you have like 40 people to help you manage like this, or what do those numbers look like?
No, peak season will have probably around 15 full-time equivalents, maybe, yeah, somewhere around there. It's hard to calculate with lots of part-time staff and all such, but we're an average level crew, I guess. So yeah,
Oh,
but
okay.
fantastic crew though.
Excellent. So yeah, I just wanted to mention that. So you're working with normal crew size. Of course, some places have 3 or 4 people,
Yeah.
but or less. But other places have 20 or 25 or 30. So I would say the numbers that you're working with are pretty average. And it's a busy golf course. It's some places have the luxury of closing for a month or two or a season. And those kind of places also could implement this kind of thing during their closure period, but you don't have a lot of closures if you're putting through that many rounds, do you?
We don't, but we do. I'm always envious of Chris and his winter top dressing before the snow. But we do have a lot of rain, so we try to put a lot of top dressing apps or the heavier apps in November, December when we get some pretty heavy rainfalls. Occasionally, we will be closed the next day because it's so wet, but we like to use that rain and the lack of traffic following it to work some sand in without any effort. So that's our little cheat there, I guess. So,
And can we talk about the nitrogen efficiency calculation? Because this is, I think, tied in with what's happening. I'm going to bring up the chart of the entire 0 to 6 centimeter layer. So what you've seen happen there, if we combine the 0 to 2 centimeter depth, 2 to 4, and 4 to 6, look at those organic material numbers. In 2023, you were at the peak. That was 7% through that entire depth. And you've gone down from 7 to 6.5 to 5.7. And this year, it's now at 4.6. And that's because the organic matter, the total organic material, at the 0 to 2 centimeter depth is going down. At the 2 to 4 centimeter depth, it's going down. And at the 4 to 6 centimeter depth, it's going down. And so if we combine that, it goes down. So we've got less organic material there. And it seems, if we look at your nitrogen efficiency calculations, it seems that nitrogen might be coming from the soil and not only from nitrogen fertilizer applications.
Yeah, so this is theoretical, as you and I talked about. So we take the nitrogen applied, and we also then take our clippings, and we're able to calculate the nitrogen amount in the clippings to get an amount of nitrogen harvested. So in 2021, we were 36% efficient. So we recovered 36% of the nitrogen put down. Is that correct, Micah?
That's right. So the way that this works is everybody knows their nitrogen rate. Most people don't do the step of calculating how much nitrogen they may have harvested in the clippings. That's the nitrogen rate that you apply. That's not theoretical. That's what you applied. And the I've got some blog posts about this, or some I've explained this in various seminars and videos and podcasts and so on. But we take the clipping volume, and depending on the grass species that we're working with, we can then convert it to an estimated dry weight. And once we have the estimated dry weight, we look at what species we're growing, and we look at what's normal for nitrogen in that species. And then over the course of the year, we can look at the total amount of clippings harvested, how much that would have weighed if it was dry, how much nitrogen was in those clippings, and then we just compare those. So how much was harvested compared to how much was applied. And you said 36% in 2020,
One.
2021. Okay.
Yeah. And then 2022 is 34%. 2023 was 76%. So we started to see some more efficiency there. 2024 was 95%. And the average for 2025 is 121% efficient. So the trend of that, while we can't say the numbers are perfect because there's some theoretical in there, the trend is going in the right direction, and that is immediately opposite of the trend of the organic matter in the 0 to 6 centimeter depth as well. So I think, I mentioned before about how we're just feeding the plant and creating a very efficient system, and I really do believe that's what's going on here. So,
And this is with nitrogen rates going from about 2 pounds at the start, 2 pounds per thousand, or 100 kilograms per hectare, down to last year of a little bit less than a pound, a little bit less than 50 kilograms per hectare.
yeah, yeah, and you can our clipping rates. So the highest clipping volume for the annual total was in 2025. So we got the most clippings last year, putting down the least amount of nitrogen, and of course dropping our OM numbers at the same time.
So, yes, some of this stuff just seems to happen naturally if you don't over apply. I over apply nitrogen. And I will just say here that if you apply a whole bunch of sand, you need to generally apply nitrogen to stimulate a growth rate that can allow the canopy to accept that much sand. And and I think that what happens is we end up producing, maybe we're producing more organic material than we realize for every unit of nitrogen applied, which goes back to a conversation that it goes back to a question you asked me one time in Vancouver 8 years ago, and that's a good one to. Now we've got some data. Maybe from the data that you have now, we can try to calculate that value of how much does 1 gram of nitrogen cost you in terms of extra mowing, extra top dressing required, and so on. But we're not going to go into that we're not going to go into that in this conversation. But it's how do I explain this? It seems like not overstimulating the grass to grow by not applying too much nitrogen can have benefits that may be greater than we might expect in terms of plant health and creating the conditions in which the soil microbes break down the organic material in the soil and give us some of the OM246 results that we're looking for free in a way, without us having to disrupt the greens by coring or punching hole, solid tining and filling the holes with sand or whatever.
Yeah, and I think at the end of the day, I mean, we've talked in the past about, and you talk about this a lot about the goal, the end result is what are the performance. Like we could have great OM2 numbers, but if we're not performing, then what's the point? But we're really happy with our greens, and members are as well. And I think my biggest being able to reduce the top dressing amounts year over year and reduce the actual applications of top dressing amounts planned in the year, then as we space those out, we were able to have more consistent days in a row without being interrupted by a top dressing application, which is going to cause less than ideal conditions than if there wasn't sand there. So, we're going to be applying top dressing 7 times this season. Two of those will be in 2026. Two of those will be in our overseed times, and then I'll be able to push the other ones into the winter months with the rainfall. So there'll be very, very minimal in-season top dressing, and I think that allows us to have the greens as best as possible on a daily basis.
And you don't see layering problems or infiltration problems happening with these kind of numbers or with the lack of punching holes.
Definitely no layering problems. And we talked about on the last podcast, we have 3 or 4 greens that are traditionally not great infiltration greens. They're actually the lowest organic matter greens typically. And those have been issue greens since the construction of the course and speaking with past superintendents. So it's something we're rectifying and doing some drainage work on. We found 2 drains that were completely exit drains that were completely covered over in the last couple of years. So trying to do some work there, but we're not seeing any issues as far as organic matter percentages and infiltration rates. So,
and one more thing, you said this year, the 2025 season, you had the highest annual total of clipping volume. And did you apply less growth regulator?
so we played around with a new this year and last year in the spring, and got away from that. I didn't really like how it affected the greens. So, but the previous 2 seasons, or most of the previous seasons, there's really no growth regulator. We just use Primo now, and we use it in August, September, when we're not applying nitrogen, but our growth still exceeds what we'd like to be for GVX. So then we'll touch it with a little bit of Primo just to kind of bring it down to where we want it to be.
So, in among your peers, would you say that you're applying less growth regulator than most people?
Yes, I would think so. In the area, it's more common to have a regular growth regulator program, but I wouldn't say unheard of to not be applying it either. So,
Okay, so you apply a little bit, but it's just at the peak growth seasons
yeah,
to keep the grass from growing more than you want to. It's not
yeah,
uh, a program that you apply all through the year to suppress growth.
yeah, correct.
Cool. Well, that's fascinating. I think that these results get so valuable as they form a timeline, and as you can see how the work that you've done has a effect on the organic material in the soil, on the surface performance, and how the inputs can be adjusted to be even more efficient. So to get the same or better result for every unit of sand applied and for every unit of nitrogen applied. And I guess you also calculate your average organic matter accumulation rate. That's been going down too. And we talked about this. It's too many numbers for a podcast, I think. So we're not going to dive into that. I said maybe I'll do a blog post about this one. Your organic matter accumulation rate, which is a calculated value based on how much sand was applied last year. So it's like a net accumulation rate. As your nitrogen application rate goes down, your organic matter accumulation rate has gone down also. And it's like, oh, well, that's no surprise. But the results you get by paying attention and then making intentional changes to the management in response to what you're paying attention to is impressive. And I like to see these results where the greens get more and more consistent and you're still producing these kind of surfaces that are letting 50,000 plus golfers enjoy those surfaces.
I love to doubt myself and challenge myself in directions we're going, but as the numbers and multiple numbers, as we've touched on some today, are all going in the direction we'd expect, it's getting harder and harder to doubt the success of this program. I'm really excited. So
Good. Well, this is where I say for anybody that's listened to this far, if you think that this is fascinating and you want to hear more about it, please send me a note or send TJ a note, and we can set up maybe an ATC office hours that will just be all about the numbers, and we can show maybe some more of the numbers, and we can talk about some more of that. But I think you've explained practically how you adjust the sand, how you calculate the different amounts of sand, how you apply the nitrogen, what the base rate is in the tank, how you separate that so that you can apply wetting agent and iron the same to all the greens, and then you just adjust the nitrogen rate and so on. So I think we covered the results, the methods, and everything. If people want to know more and they do find this really interesting and have some questions, do let me know, and we'll do an office hour sometime.
yeah, that would be great. I've got a whole slew of numbers that we haven't even talked about yet. So I went down a deep rabbit hole a month or so ago, and yeah, it's got some fun stuff stored up.
I know, yeah. So yeah, some proposals of nitrogen efficiency changes through the year based on temperature, right? Is that the rabbit hole?
Yeah, varying the curve instead of a set curve. So yeah, it's kind of neat. So
cool. All right. Well, TJ, thank you so much for joining me on the ATC Double Cut today. That was something that I've been wanting to talk about, and I'm glad we finally got to. And it's not just to talk about it, because we talk about this every now and then, but I want to share it. I want other people to be aware of it, because these are the kind of results that I think a lot of people are trying to achieve, and I want to let people know that it's possible to achieve this, which we're not just talking about what happened over 1 year. Now we're talking about what's happened over the past 3 seasons, and we're also talking about what happened over 4 or 5 seasons ago. But the improvements in moving the organic material down and making the greens more and more consistent, that's been a steady trend over the past few seasons, and it's nice to see. So congratulations, good job, thanks for sharing all of this, and have a good night.
yeah, thanks very much, Micah. Always a
All
pleasure.
right. A pleasure for me also, and thanks everyone for listening, for watching. I will go ahead and sign off now with the promise to be back soon with more interesting turfgrass information. I will sign off now for ATC from Bangkok, Thailand. I'm Micah Woods. Bye-bye.